morning. Welcome to
KidMath162.
KidMath162. So we're in the section on rational functions in our algebra book, but we spent the whole morning working on solving a rational function example. So for our movie, I'm going to do one of the examples that they did, just some more lecture style today. But they're introducing a really neat concept called partial fractions. So sometimes you have rational functions that look like this. So easy expression on the top and say quadratic on the bottom. And we're going to break those up into two expressions that just have constants on the top and linear terms on the bottom. So maybe this is a little easier to understand, but sometimes maybe not. It's actually hard to tell, but this is a neat concept of breaking a rational function into two other rational functions. It's called partial fractions because you're breaking it up into two fractions. I guess that's where the names come from. I learned this when I was in high school in calculus. So this is a concept that's useful in calculus, but it's probably useful other places too. So how do you think we're going to solve this? We're trying to find what a equals and what b equals.
Well, we could factor the quadratic.
Yeah, well, you see that x squared minus 5x plus 6 factors into x minus 3 times x minus 2. So this side we've already got figured out. So what do you think you would do?
Well, we can multiply. We can get rid of the fractions.
Right, we can try to get rid of the fractions. Right? So if I multiply everything by x minus 3 times x minus 2, that's going to be x squared minus 5x plus 6, right?
So that cancels that.
Right, so when I multiply the whole thing by x squared minus 5x plus 6, it's going to leave an x minus 3 times b, an x minus 2 times a, and it's going to be equal to this. So we're going to get 2x equals x minus 2 times a plus b times x minus 3. Do you see that?
Yeah.
Okay, and that's because this is x minus 2 times x minus 3, so I can do some canceling. Well, this is nice because this says 2x equals, on this side I have x times, I have an a plus a b.
Yep.
And then I have a separate minus 2a and then a minus 3b. Okay, and this is supposed to equal 2x. Okay, so what do you think that means? This is step now of understanding what this equation means is the whole key step in partial fractions. Because clearing out the fractions isn't really that hard. Okay, so what do you think this means if 2x equals x times this plus some other constant?
Well, then x has to equal this all over 2.
That's true. That's true. What else does it mean?
Well, the x terms are going to be coming from this.
Right. That means that a plus b has to equal 2.
And then this has to be 0.
That has to be 0. So it has negatives. So negative 2a minus 3b equals 0. That's the same thing as 2a plus 3b. Why is that the same?
Because you just multiply everything by minus 1.
Right, and minus 0.
0.
Okay, how do I solve an equation? A set of equations like this.
Well, we want to eliminate one of the variables.
Okay.
So let's multiply this equation by 2.
All right. 2a plus 2b equals 4.
Now we can subtract. We can subtract down and we get. Or let's subtract up, so we get b equals minus 4.
B equals minus 4. Okay. And we remember a plus b was 2, so what does that mean a is?
A is 6.
A is 6. So that means this expression, 2x over x squared minus 5x plus 6 equals 6 over x minus 3 plus negative 4 over x minus 2. Okay, so what looks to be a fairly complicated expression.
Just factors into this.
Well, not factors. Breaks apart into, it's not that these two things multiplied together equals this. Those two things added together equals that. It's a neat simplification. It's actually a really neat simplification. And the funny thing is there's not a great analogy to doing this to regular fractions. We don't we don't usually break apart number fractions this way. Although there is one cool topic called Egyptian fractions that maybe we should talk about. Anyway, good job this morning, huh? Good job.